Okay, so we picked up back here in your 5-1 notes where we left off yesterday. Okay, this one, number 4, tangent squared y minus secant squared y. All right, so one of my suggestions that we've used for the previous 3 examples were to convert everything into sines and cosines. Okay, so that is one method, and a lot of times that's helpful. Okay, now on example 4, that's not going to be as helpful. Okay, so the clue here is that you have these trig functions that are squared. Okay, if you go back to these Pythagorean identities, okay, that's what these Pythagorean identities are built on, are these trig functions that have been squared. Okay, so take a look at those. And if you go down to number 4, look, you can see you've got a tangent squared y minus secant squared y. Well, right here, you have a trig identity that uses both of those. Okay, so 1 plus tangent squared equals secant squared. So 1 plus tangent squared equals secant squared. Okay, so I'm just rewriting this down here so we can look at it. All right, so what could be helpful about this statement? Well, there's a couple of things. Right here, you've got this secant squared y, and secant squared is equal to 1 plus tangent squared. So you could make a substitution for this, okay? And that's going to work out nicely for us because you'll see what will happen here in a second. Now I'm subtracting all of this, 1 plus tangent squared. Okay, so tangent squared y minus 1, but you are also subtracting that tangent squared, and I should have changed that to a y instead of leaving it a theta. Okay, so look what happens now. You have tangent squared y minus 1 minus a tangent squared y. Those are going to cancel out, and you get negative 1. Okay. All right, now let's have another conversation. We don't always see the same things when we look at these expressions. Okay, so let's say I see this and say, okay, there's tangent squared. Here's tangent squared. And if I want to, I could solve this equation here for tangent squared. All I'd have to do is move this 1 over to the other side. Okay, so I might say, I'm going to do tangent squared theta equals secant squared theta minus 1. Okay, so that means I could now take this and make that a substitution in for tangent. So I make this substitution and it becomes secant squared theta minus 1 and then minus that secant squared, well, it should be y. Keep doing that. Okay, so this should be a y. All right, so I have secant squared y minus 1 minus secant squared y. Well, look, those secant squareds cancel out. What do you have left? Negative 1. Okay, so I show that to you to say that there very well could be more than one path to get to the same result. Okay, so as long as you are following the rules and you take a different path than your neighbor does, then that's okay. All right, so as long as you are still making good decisions with your substitutions or when you're simplifying, and as long as you're algebraically correct, then you can go down that road. All right, and you might get there a different way than somebody else does. Okay, so on a lot of these, there's more than one way to think about them. Okay, so let's go on to number 5. All right, so here's another one that has squareds in it. So that, again, that kind of clues you in that using your Pythagorean identities might be helpful. Okay, so let's look at this one right here, cosecant squared theta minus 1. Let's see if there's anything. Cosecant squared theta minus 1. Okay, well, this third one right here, 1 plus cotangent squared equals cosecant squared. All right, I'm going to jot that down. So 1 plus cotangent squared theta equals cosecant squared theta. I think I got that right. Yep. Okay, well, this is solved for cosecant squared, but if I look at what's here, I've got cosecant squared minus 1. So can I manipulate this Pythagorean identity to mimic this cosecant squared minus 1? And you can. I can subtract this one. It's an equation. I can subtract that one from both sides. And I get cotangent squared theta equals cosecant squared theta minus 1. All right, so I can make a substitution for cotangent squared in for that. So I'm going to go cotangent squared theta and then times sine squared theta. Okay, so that looks better. All right, well, and again, I still have things that are squared, so I could go back and look at these identities, but I have sine squared theta and sine squared plus cosine squared theta equals 1. So yes, I can manipulate that Pythagorean identity and get sine squared alone, but that's not really going to help me, okay? Because then I would be changing it to 1 minus cosine squared. That's just going the opposite direction you want to go. Okay, so we use a Pythagorean identity. We got to simplify down some. So what else could we do? All right, we'll go back to that first technique I was showing you, rewriting things as sines and cosines. So if you are to rewrite cotangent squared, that's going to be cosine squared theta over sine squared theta. And then you're multiplying times a sine squared theta. Okay, so do you see what's going to happen in this next step? This sine squared theta is over 1. I now have a sine squared in the numerator, a sine squared in the denominator. And so once I simplify, I get cosine squared theta. Okay, so I'm down to one like trig statement there. Okay, so I would say that's a much more simplified version than where we started. All right, let's look at number 6. Okay, so number 6, again, you have this tangent squared theta and it's 1 plus tangent squared theta. So hopefully you're starting to catch on. Hey, go look at your Pythagorean identities, see what we have. Okay, well, we used it right up here. Okay, we're back up here at the top of the page in red. I had jotted that down. So 1 plus tangent squared is secant squared. Okay, so I can make a substitution, and I'm going to rewrite this as cosine of theta times secant squared theta. Okay, so that looks like a good substitution. Okay, now I would suggest rewriting with sines and cosines because secant is 1 over cosine. Secant's the reciprocal of cosine. Okay, so that's going to be 1 over cosine squared. Okay, this is going to be over 1. You can reduce. So you can reduce out a cosine here and take out a cosine here. Now this is cosine squared, so that does mean cosine times cosine. So if I simplify out 1, I still do have one other cosine statement left. So this ends up simplifying to 1 over cosine. Okay, well, 1 over cosine is secant. So this simplifies to secant of theta. All right, number 7. All right, so what method should I take? So far, kind of the two things that I've been showing you have been either change things to sines and cosines, or is there a substitution that I can make with a Pythagorean identity that's going to be helpful? All right, so this one, I don't see anything squared. So at least right now, I'm not thinking a Pythagorean identity is going to help me any. Okay, so let's try changing things to sines and cosines, and we'll see what happens. All right, so cosecant is going to be 1 over sine, so 1 over sine beta. Tangent is sine beta over cosine beta. And secant is 1 over cosine beta. Okay, so multiplication comes before adding. Okay, so I have sine betas that will simplify out. So this first kind of term here, I'm going to have a 1 over cosine plus 1 over cosine. Okay, so can I add those fractions together? That kind of seems to be the next logical move. You can. Okay, they both have a common denominator. So when you add them together, this is going to be 2 over cosine beta. This can be rewritten as 2 secant beta. Okay, all right, because cosine, the reciprocal, a cosine is secant. So 1 over cosine would be secant, so 2 secant. All right, let's go to number 8. All right, so we have a couple of techniques. Changing to sines and cosines. If I'm seeing something squared, check out your Pythagorean identities and see what might be able to help you. Another method you can use is factoring. Okay, so look at this. You have a common monomial factor. Okay, if you look at both of these terms, you have a sine alpha that can be factored out. Okay, so this would be a cosine squared alpha minus 1. Okay, because remember, if I do sine times cosine, that takes me back to this first term. Sine times 1 takes me back to my minus sine alpha. Okay, so I factored out that common monomial. All right, so now take a look at what you have. Well, look at this cosine squared minus 1. Okay, that's going to come from a Pythagorean identity. Okay, the first one we looked at. It's sine squared plus cosine squared equals 1. All right, so can I rewrite this as a cosine squared minus 1? Can I manipulate this equation? And you can. Okay, so I'm going to want 1 move to the left because I want to be able to subtract 1, and I'm going to want to move the sine squared to the right. Okay, so if I move the sine squared to the right, subtract sine squared on both sides, you're going to get cosine squared theta equals 1 minus sine squared theta. Okay, now remember, I want cosine squared theta minus 1 on the same side, so I'm going to subtract 1 from both sides. That's going to cancel there. You will get cosine squared theta minus 1 equals a negative sine squared theta. Okay, so take a second, look at what we did. All right, we moved the sine squared to the right side, and then we move the 1 to the left side. So now we have a substitution we can make. We can make this negative sine squared and substitute it in for that cosine squared minus 1. All right, so now we have sine alpha times a negative sine squared. That'd be an alpha. So this is going to be a negative sine cubed alpha. And there's your simplified version. Okay, I'll be back for part 3 with examples 9 and 10 to finish this lesson.